My name is Richard Henry, and you're listening to the COVID-19 Challenge podcast. So as we've discussed previously, wild-type humans, those who are young, healthy, thin, fit, active, don't suffer unduly from this virus. Now, that's a very superficial, simple answer that sort of summarizes all the work we've done before. But we can't all be young, healthy, thin, and fit. And so what can the rest of us do to mimic that human phenotype? And it turns out there's quite a bit we can do, particularly based on understanding. And a lot of the stuff is being done. Just as we've been taking chicken soup when we get sick all these years, there are treatments out there, and they're all associated with COVID right now. But we're going to just try and make some sense of it and put those treatments into categories as to how and where they work. And then it'll sort of make you feel a bit better about maybe even using some of those interventions. So the idea is to reduce aldosterone-mediated high blood pressure. So you want to get lean, wild type, and fit exercise. The aim is to reverse or reduce aldosterone effects. Remember, aldosterone has two effects. It works on inflammation, so it's activating the innate immune system from inside the cell, where the cell can literally initiate the inflammatory signal and send a message out to the rest of the body that it's in trouble. This reaction is to both repair and repel. So repel invaders, destroy the invaders and sometimes tissue, and then repair it all. And our immune systems can actually be skewed to be more inflammatory, or they can be more lethal and directed towards killing invaders. And so we have these M1, M2 phenotypes. And just by the way we live, we can actually direct our immune system to have sort of either of those personalities. Now, it's a blend, but the immune system can be more inflammatory or less inflammatory. And the key mineral for this, comes as no surprise to you, is zinc. Our immune cells, our white cells, and particularly cells from the thymus gland itself, so our T cells, really use the proteins in them are linked or have binding sites for zinc, which makes them work properly and efficiently and effectively. And so being zinc deficient, in a nutshell, will increase our allergic response. It'll both weaken the immune system's ability to kill and be effective, but will also advance the immune system's ability to make a big, loud noise and cause harm. So zinc deficiency is fairly common, but it's not sort of epidemic. In young people, it'll be the hallmark of zinc deficiency is malnutrition, because humans who are zinc deficient, A, don't like eating, and B, don't grow very well. So if you sort of stunted growth or thin or have an eating disorder around not wanting to eat, zinc plays a key role in that. And then in the elderly, the zinc deficiency is associated with immune senescence. So a weakened immune system, particularly, again, those thymus-derived T cells, and you have a very weak immune response. And so infections can become quite easily overwhelming, which is why the elderly often die of infection. And one of the factors behind this is zinc deficiency and the downstream effects of that. So a cheap and simple, effective way to optimize immune function is just to make sure that you have enough zinc. You don't need to overdose. Too much zinc is almost as bad or worse than having too little zinc. And it really is not harmful to be zinc replete. This lecture series is not about supplements and how to take them or when to take them, which is the best. So, but it's just a matter of finding out where all these pieces fit in. You can also use zinc acutely when you're sick, but I think it's better to just live healthy and set your immune system, just as you set yourself up not to be using aldosterone very much, so you can set your immune system up to be skewed away from being inflammatory by having normal, healthy zinc levels. Next piece of the puzzle is oxidation. So recall we talked about how aldosterone-mediated raise in blood pressure increases oxidation production by the protein system called NADPH oxidase. So knocks actually splitting an electron off a hydrogen atom and giving it to oxygen in order to subvert nitric oxide. So it's done intentionally by the blood vessel in order to raise blood pressure, which when it's done on and off is easily reversible with antioxidants made in our body. But when it's done continuously will result in excess oxidative stress. So anything that we can sort of bias away from pro-oxidation would help. So again, I'm going to introduce you to a, a hormone that you've all heard about, vitamin D. So vitamin D is literally a hormone which is a lipid-soluble hormone, so it's made from the cholesterol backbone. And so it can enter the cell, can bind to a nuclear receptor, and switch on genes. So it seems to be about 400 genes that respond to vitamin D. And when you have enough vitamin D, you get an anti-inflammatory bias. So it works along with zinc, right? So zinc's going to affect the proteins that are in existence, and vitamin D is going to bring into existence proteins that are going to, just in a nutshell, give you an anti-inflammatory bias. So not surprising that they work well together. So where do we get our vitamin D? We get it from sunlight normally, and you can supplement it. But if you go out in the sun, which is what we evolved to do, to be outside, there shouldn't be any shortage of vitamin D at all. So zinc and sunshine will improve our immune system, reduce immune senescence, reduce the inflammatory bias, and will make us healthier. It's surprising, but it's sad that in our society today, many of our elderly people are locked up in care homes for their safety, and end up with a diet that's quite markedly deficient in zinc, usually, and also they're sunshine deprived, and so it's not surprising that their immune systems become quite markedly senescent and exposes them to risk of dying from infections. Anyway, let's go back to vitamin D. How much do you need? How much vitamin D does somebody need? Well, it depends. It's like asking how much insulin should a diabetic take. What's the healthy dose of insulin for a diabetic? Well, it depends on their blood glucose and many things. So the diabetic finds out by measuring their blood glucose and then working out a regime over weeks and months that works. But that will change with their diet. So equally, how much vitamin D do you need depends on how much vitamin D you have and how much you're going to keep on making. You make it by going out in the sun, and it needs to be sun which is of a certain wavelength. So winter sun in the northern climates is where I am up in Canada. You've only got about 4 months where you can actually make vitamin D. If you sit behind a glass window, the sun, that wavelength is going to be filtered out as well, so you won't even make vitamin D then. So although you can still get sunburnt in the winter sun, you don't make vitamin D. That may explain some of the inflammatory diseases associated with living in the northern hemisphere, but it's not all just vitamin D. So sunlight activates systems in the skin, which will convert cholesterol pro molecule into vitamin D, which then goes on, gets activated by the liver and the kidneys. We can see how in nature things are sort of edited and passed around and shared, so that you don't just get one organ providing something that the other organs may not want. So everyone has a say in things, and it's the same for vitamin D. Ideally, if you had 1 or 2 hours of sunshine on your skin, that's on your, not just your face and arms, but probably on your whole body, you're going to make about 10,000 units a day of vitamin D, and this gets stored. It's a fat-soluble molecule, so it sits in fat and is stored very actively for those winter months and for those times when there is no sunshine. So we don't need to make vitamin D every day. We can go for weeks and months without vitamin D, although those levels will gradually reduce. So obviously, the more sun you get, the less vitamin D supplementation you need. And again, we come back to obesity. If you have a big storage area, your vitamin D is going to be picked up by all those cells. And so the level in those cells for the same dose that you've either made from the sun or eaten is going to be lower. So you'll have a lower blood level and so therefore a lower effective level. So sunshine, being skinny, healthy, wild type, you're going to have good levels. Staying out of the sun, being overweight or being obese, your levels are going to drop. And so the best thing would be to measure your levels and take as much as you need to get your blood level up to that level, and then watch what happens over different seasons. If you need a short answer, remember you make about 10,000 units of vitamin D equivalent a day by being in the sun, so that's not a bad sort of number to keep in your mind when you're thinking about supplementing, particularly on days or weeks or months when you're not able to get out into the sun. Now, there's another very important enzyme that skin makes under direction from sunlight, and that's called hemoxygenase. And I certainly hadn't really heard about it. So let's go back up a little bit. As everybody knows, that hemoglobin is a molecule that can carry oxygen. So it's kept in little capsules called red blood cells that are beautifully shaped to allow maximum surface area to get that oxygen to go in and out of the red blood cell. And carbon dioxide is working opposite. So we need iron to attract the oxygen and then take along, and then the oxygen gets dumped off in an area of the body where there's a lower oxygen tension. Now those red cells and that hemoglobin doesn't last long, so red cell turnover is about every 3 months or so. So every hemoglobin molecule is turned over in 3 months, and when it's broken down, there's that iron molecule that needs to be disposed of. Now, iron and oxygen, particularly iron and the free radical oxygen, can really create havoc in terms of producing a molecule called hydroxyl, or OH, which has the strongest and most lethal oxidative effects. So you really want to keep iron away from any oxidation reactions if you can. And so we've evolved to have this enzyme called hemoxygenase, which disposes of broken down hemoglobin and the iron. And it's made in the skin with the help of sunlight. So again, sunlight is not just a vitamin D producer, but actually helps skin make about 300 or 400 different protein signaling systems, but a really strong one, particularly in this role, is hemoxygenase, which then would work as an antioxidant. So let's come back to aldosterone again. Remember, it's increasing that free radical to bind nitric oxide. And so we've developed antioxidant systems, and probably the easiest ones to know about and the ones that everyone should know about are vitamin C and glutathione. So these two work as a pair, and they literally end up taking that free radical, that oxygen with the extra electron, taking that electron and actually taking away from oxygen and giving it to sulfur. The sulfur electron bond is a lot more stable, and so sulfur is a better way to get rid of the extra electron. And so eventually that free radical signal is switched off. So let's come to vitamin C. All animals in the world make vitamin C except primates, which includes humans and guinea pigs. So we have the gene to make the enzyme to convert glucose into vitamin C. But somewhere along the line, tens of thousands or hundreds of thousands of years ago, we lost the ability to transcript that enzyme, that gene to make the enzyme. And so we don't have the enzyme, which is called GULO protein, which would then convert glucose into vitamin C. It's interesting, especially those of you who are diabetics will know that when you get sick, your glucose levels go up and you need more insulin. So in times of stress, so if you take steroids, your glucose levels go up. And I suspect that's because in other animals, they use that higher glucose level quantity to make more vitamin C, which is going to counteract the oxidative effect of the inflammatory response to kill the invaders. And so we don't make vitamin C, and at times when we're sick, we need more. It looks like again, we're told how much vitamin C do you need? Well, to stop being severely vitamin D deficient, you need about 300 or 400 milligrams a day. Um, um, but that's a severe deficiency. To be replete and have enough to be healthy, you probably need more like 1,000 milligrams a day, because vitamin C is really good at integral to making things like collagen, which is your connective tissue. And then, of course, when you're sick, we know that animals will push their vitamin C production up 10 to 100 fold. So at times when you're sick, using that vitamin C is actually useful. It's not going to kill the virus. It's just going to reduce the oxidative stress from that virus and probably allow you to recover a bit quicker with a bit less of a severe disease. But it is dose responsive, right? That vitamin C gets used up. And so it looks like studies done in intensive care units with people who are septic, it looks like 6 to 10,000 milligrams a day is probably useful and helpful. Going higher than that may not be in that situation. And to get those bigger doses, you need to go intravenous. So again, why not just have enough vitamin C in you, and you have to consume it. It's not going in the sun or any other way. Vitamin C in humans needs to be consumed. And yes, it's excreted, but it's excreted in its used up form. And so it comes in, does its job, works as an antioxidant, and away it goes. Some of it is stored, and you might as well get your storage sites filled up. Now, vitamin C then passes that electron onto glutathione. And glutathione is 3 amino acids, and the middle one of the 3, it's almost like it's got 2 sidekicks looking after it, is an amino acid called cysteine. And cysteine is one of 2 amino acids that have sulfur in it. And that sulfur gives that peculiar smell, and that's what you associate with things like garlic and broccoli. You also get it, so you get it in vegetables and meat. The cysteine, when it's is converted into glutathione, and the whole system is sort of regulated by glutathione peroxidase, which is another enzyme. Now, the key to understanding glutathione peroxidase is that it is switched off by a high glucose level. So diabetics who suffer a lot of excessive oxidative stress, one of the ways that this is done and why it's related to poorly controlled diabetes is the high glucose level switches off glutathione peroxidase, which then results in increased vascular oxidative stress, which then rapidly speeds up oxidative disease. Interestingly, diabetics who smoke, who have a little more oxidative stress, will get disease quicker. Diabetics who eat poorly will get vascular effects quicker. Obese diabetics with hypertension who smoke and eat poorly will end up with complications within 5 to 10 years of being diabetic. Another little unknown thing is that acetaminophen, or Tylenol, is metabolized in the liver and does affect glutathione levels. And in fact, an overdose of Tylenol, when it causes death, causes liver failure from deficiency in glutathione and cysteine itself. And the treatment, if given early enough, which is cysteine, in a form that's absorbable called N-acetylcysteine, will actually prevent that overdose person from dying. And so, chronic use of acetaminophen is quite common. We use it when we're ill, but it probably also has a little bit of a role in oxidative stress indirectly by gobbling up cysteine and therefore glutathione. So it's again, this is not a lecture series about naturopathy and where to get supplements from. But when you hear people talking about antioxidants and N-acetylcysteine, and also how diabetics have an increased risk of dying with COVID, this may play a very integral role because of the oxidative nature of the illness and the antioxidant effects that diabetes has. So we've looked at zinc, vitamin D, and vitamin C, and sunlight involved in COVID. And you can see these often end up on sort of fringe websites saying that these things work, but there's no really evidence for it. I just want to say that there's not only there's not only evidence for it, but there's also mechanisms. And I think once you understand the mechanisms of how things work, then it's easier to appreciate whatever research is done. And you can see how sometimes the research can be flawed and not really show any benefit because of the way the research was actually carried out, which showed no real understanding of the mechanisms of these things. So again, we've got some natural things that really shouldn't be discounted. They're free, they're safe, and nature really does do it best. And again, we have a whole cadre of humans who don't do badly with the disease. So what's special about them? What's different from them, from the kind of person that we see in ICU dying? And we need to just really pick apart the science and the differences, and then the whole thing becomes quite clear. So the next step then is to say, well, we can make ourselves stronger, but what if we could interfere with the virus, right? Can we somehow make it harder for the virus itself? Can we put some impediments to the virus? Because the virus has got to come in, get undressed, replicate itself, address all of those little offspring, and off they go again. So what if you could interfere with that system? Now we know that viruses have been around forever, and so all living creatures or living cells on Earth have evolved a viral defense mechanism. Otherwise, they wouldn't be here. So they've all learned to live with viruses. And some of our best friends, which are plants, also get infected by viruses. And so they make different chemicals that will impair viruses. Remember, humans do too. We make surfactant in our lung, which is a set of proteins that will actually bind to viruses and stop them getting into our lungs. And so it's not unusual or not surprising that plants, and we call them, the ones we like are herbs, will make compounds that will significantly stop viruses from surviving. There are many herbals that work. The Chinese have a slew of them. The North American Native people have herbals that work. And again, I don't want this to be for me to be talking at length about supplements, but just really where they fit in. Now, the basis of the pharmaceutical industry came from using herbal medication. So humans over the millennia have realized that certain plants will work in certain illnesses, and that's translated into the pharmaceutical industry, where there's a bit more chemistry involved. The product is a bit more controlled and pure, but still we're making a compound that interferes with some disease process. And the two that are associated with COVID are ivermectin and HCQ, hydroxychloroquine. So ivermectin is used against parasites, and hydroxychloroquine also against parasites, malaria. And so these chemicals are quite safe to take. Humans have been using them for decades and more, and they can also be taken prophylactically, and they interfere with the viruses or the invading organisms' reproductive cycle. So again, we're going to pick up something that, yes, it's from the pharmacy, but yes, it's fairly safe and can be used either prophylactically or early on in the disease. The trick is to use it early on while the virus is still replicating, and not later on when we've got into COVID syndrome, which is just the after effect of the viral inflammation and aldosterone-induced inflammation. So we can change our phenotype to a healthy state by reduce aldosterone activity. We can change our inflammation bias to be non-inflammatory by sunlight through vitamin D, hemoxygenase, and zinc. We can really very simply increase our antioxidant levels by paying attention to things like vitamin C and glutathione. There are many other antioxidants, and they all work together. But the two sort of the sort of dynamic duo in our system is actually vitamin C and N-acetylcysteine, because we've evolved with those. Although humans lost vitamin C along the way, it doesn't mean to say it's not important. We live without it because we can eat so much of it through our plant-based diet. We've now got two drugs, ivermectin and hydroxychloroquine, that can be used either prophylactically or early on in the disease to act as a herbal. And there are many, many other herbals that can be found and bought from quite reputable people that have a long history of being very effective, even in the last SARS outbreak. Now, the other thing we come down to then is further looking at the pharmaceutical industry. We know that this is a renin-angiotensin system disease, and so are there drugs that will block this system from being overactive? And the answer is yes. We can use ACE inhibitors, which then block the protease that cuts the signal, that edits the little messenger and turns it into angiotensin 2, which is pro-inflammatory, raises your blood pressure, so we can reduce that enzyme's activity. We can block the receptor that angiotensin 2 binds to, and that's called an angiotensin receptor blocker. Those drugs, generic names end in sartan, so we call those the sartan drugs. And then we can go further down and block the mineralocorticoid receptor, which is where aldosterone works. Remember, angiotensin calls up aldosterone to come and help, and aldosterone works again in the nucleus to get genes to activate and transcribe and make proteins. So that receptor is on the inside of the cell and on the nuclear membrane. And the two drugs that we have is spironolactone, which is very well known, it's been around for 50 years, and then eplerenone, which is very, very little known, as I think is a very nice drug, but has hardly seen any use. And the last of all, dexamethasone, which everyone's heard of, which is a steroid-like molecule which decreases aldosterone production, so it suppresses aldosterone production. It's not directly a steroid. I don't know this for sure, but it probably doesn't bind to an oxidized mineralocorticoid receptor as cortisol does. So in an oxidized state, when you're sick, cortisol will actually work like aldosterone, and you really don't want that in this situation. And that's why high-dose steroids can be actually counterproductive and may have accounted for many of the deaths during SARS outbreak 17 years ago. So we can prevent excessive aldosterone derangements with inflammation oxidation causing edema, and also sodium retention, potassium loss also contributing to edema, and those electrolyte imbalances and oxygenation difficulties with the lung, which are then causing acute death. Right? So just to review then, looking at this, none of those strategies are either dangerous, expensive, or life-threatening. They don't give an advantage to anyone who's advocating for them. There's no conflict of interest from people who are sort of trying to highlight the science. The science is very deep. The science goes back 30, 40 years, is published in peer-reviewed journals. It is all disparate and separated, and it's hard to bring it all together. It's certainly taken me a few years to do that. But in making yourself healthy and robust and being a wild-type human against this virus, you're doing that for many other things. And although we know that wild-type animals are healthier, they may not live as long as a domestic animal, but they die from wild-type things like being attacked and eaten by other creatures. And so, could humans get the best of both? Could we have a wild-type phenotype but live in a domestic environment where we were relatively healthy? So this virus again has come to challenge us and to challenge our ability to respond to it. Just a little quick editorial note, as the human condition and the human psyche, we've been conditioned over centuries to believe that salvation and passage to heaven and to the afterlife was through the church. But it came at a fee, right? As long as we were card-carrying members of the church and we were blessed and had fulfilled all the rights of whichever church had got to us first, we were promised salvation and a free passage to heaven. Over the last 100 years, we've kind of moved away from religion, and our new religion is now science and health. And again, if you obey the healthcare industry, you are promised the best survival rate and the best health if you listen to the practitioners. And again, it's at a fee. It's a rather exorbitant fee. Freedom from from those types of tyranny is scary, because freedom requires you to take responsibility for yourself. So, as we've done with religion, people have largely worked out that we don't need an agent to get to heaven, that we can do this ourselves, that we can have a covenant which, with our understanding and our interpretation of God, and we don't need to pay a fee. And there are some of us amongst us who realize that the same thing can happen with the healthcare industry, that we don't need to treat our high blood pressure with medications, that we can do it naturally. And so, again, with this COVID-19 epidemic, we can listen to what's told of us. And I know in my hospital, people get put on oxygen, a bit of dexamethasone, and they just ride it out and see if they survive. When in fact there are lots of things we can do to both prevent being really, really sick and to survive the illness and get through fairly unscathed. At the moment, we have no one to blame for this epidemic. We have no one to blame for the treatment that's being offered. We are told it's the best options there are, and this is all peer-reviewed and scientific, and we are to believe the science. We are to not believe any of the pseudoscience, which is anything that's not owned by the health system. So let's go back. Let's ignore conspiracy. Humans are now being challenged with a virus that is literally attacking the phenotypic humans who are domesticated, who are overweight, unfit, unhealthy, malnourished, and all of us who don't have an understanding of the renin-angiotensin system, which is one of the most powerful systems in our body, and in fact within this pandemic is literally the loaded gun that is killing some of us.